Hello everyone. So we have solved these questions from the chapter hydrocarbons, right? So now let's try to solve one more question in this particular video. Okay. So I hope you are getting all the things whatever I am telling you. If you get stuck or if you didn't understand anything, you just let me know in the comment section. I will try to make a different video or else I'll clear your doubts in. Okay. So yeah, so these are the questions that I have solved. If you didn't watch these videos, if you have any doubts while solving your previous year questions, you can check these videos out. You can check these videos in order to clear your doubts. Okay. So yeah, these are the questions. All these questions we have solved, and now let's solve this particular question. So here they have given butadiene and hydrogen. So here this is one important thing that you need to take care. 1 mole of, see here hydrogen they have given which is 1 mole are separately treated with palladium carbon in the presence of carbon and sodium in the presence of liquid ammonia to give products X and Y. So if we get to know products X and Y, then we can compare and we can tell the what are the incorrect statements. So read the question properly, because in some questions they might ask you correct statements and in some questions they might ask you incorrect statements. Okay, need to be careful while reading the questions. In some questions they might ask you which are the following are correct statements, and in this particular question they have asked about incorrect statements, so you need to read carefully. Okay, so even I have did the mistake when I have given my JE, so that's why I'm telling you with experience. Just don't neglect, don't read the question just like that. Just read the question properly. Okay, so here they have given butadiene. Okay, this is butane, right? Simple butane. This is a butadiene. 1, 2, 3, 4. So this is a butadiene, and here they have given like two reactions, H2PDC, and here they have given one more reaction, H2 in the presence of sodium liquid ammonia. I hope you know this is a type of Birch reduction. Here it will add, what it will do, it will try to convert this alkyne to alkene. Okay, happens. See, one thing, this palladium in the presence of carbon, this is a reducing agent. Okay, as it is a reducing agent, it will try to convert alkyne to alkane. Generally it will try to convert alkyne to alkane. It won't stop in between. I mean, it's not a partial hydrogenation, but as although is they have mentioned implicitly, like indirectly they have mentioned, they have given only 1 mole of hydrogen. That's why it is now it will do partial hydrogenation only, means this alkyne get converts to alkane. Generally it is a, will get the cis alkane over here, cis alkene. So here, as you know, this is a type of Birch reduction. Here we'll get transalkane, right? So it will try to add this hydrogen on opposite sides. So we'll get transalkane. So based on cis and trans only they were asking the question. So you can, or else let me write the product also over here. So what will the cis alkane means? Here the hydrogen added on same side of the carbon. So this is the transalkene. This is the cis alkene. Okay. So now let's see. X and Y are stereoisomers. Obviously it's true, right? Because cis and trans are geometrical isomers. So generally geometrical isomers are stereoisomers only. So this option is correct, not incorrect. Dipole moment of X is 0. What is X? This is X. This is Y. So dipole moment of cis alkane is 0 or what? No, right? So here there is having dipole moment. Like here, this is the direction. Overall direction will be niche, like downwards, है ना? So there is, this is having dipole. Net dipole is not 0 in case of cis, but in case of trans, the net dipole will be 0 because the groups are opposite to each other. That's why this is true for in case of Y, trans alkene. This is not true for cis alkene. So that's why this is wrong. That's what we want. Incorrect statement. So this is incorrect statement. Boiling point of X is higher than Y. So how do you need to check the boiling point? You, most of the people might get confused over here. So here you need to compare intramolecular like interactions. Just try to understand in based on like interactions. If it is having more attraction or more So most of the people might get confused in case of boiling point. How you will compare means, let's say for example, one compound is having more attractions or more intramolecular attractions, it will take even more energy, right? So it will take more energy to separate those molecules. So how you will compare this boiling point means, you just correlate with the intramolecular forces, like intra na inter. So how you'll compare this boiling point means, you just need to take care of, like, just think about attractions. If there are many more attractions, it will we need to supply even more energy. It needs more energy to separate those molecules. That's why you can think that way. Cis alkene means, see here the net dipole moment is not zero. So this is having dipole interactions. है So in this cis alkene, dipole dipole interactions will be there. है but in transalkene, as the net dipole moment is zero, mostly weak, like van der Waals forces might be there, which are very weak, right? Here this is having strong intermolecular forces. That's why you can say boiling point of cis compound will be more than boiling point of trans. So that's what they were saying, boiling point of X will be higher than boiling point of Y. So that's why this option is correct. Okay. And here they were asking X and Y react with O3 in the presence of, this is how ozonolysis simply to give, and it is a reductive ozonolysis because they have mentioned zinc over here to give different product. Let's check. It will give the same products itself. You can see here we have X as this, right? So here when you do the ozonolysis, this reductive ozonolysis, what we'll do, you just break this double bond and add oxygen on both sides. What we'll get over here, as it is hydrogen, this is simply CH3CH4. And here also we'll get 2 moles of this compound, same compound. And if you do hydrolysis to this trans alkene also, will get the same. So just don't need to no need to mention this hydrogen right over here. So I hope you understand this bond line formula, which is easy to. So here what happens if you do this ozonolysis, H2O, you just break this double bond and a similar thing will get 2 moles of CH3 C double bond O. I hope you understand. Like what, it's just nothing. You add oxygen on both sides. CH3 C double bond O, one more H is there. So that's why we'll get this. So have we got different products? No, right? We have got the same products. That's why this statement is wrong. What, that's what we need. Incorrect. So these two are incorrect statements among the given 4 statements. So I hope you have understood all these questions. So I hope you understand the things over here. Let me summarize once. So let me summarize once. See here, although palladium in the presence of carbon, it reduces alkyne to alkane generally, but as they have given only 1 mole of hydrogen, it will do, it will undergo partial hydrogenation. Okay, so this alkyne will get converts to alkene, and it is a cis. We will get a cis product over here. And in case of this is a type of Birch reduction, right? So here we'll get a trans alkene because it adds the hydrogen on opposite sides. So we will get this particular trans alkene. So yeah, that's it. Just take care of yourself and be kind. Bye.